I'm going to go ahead and record this. So for the people that are not here, there's nothing really particularly visual about this. It is pretty much straightforward stuff that I think you did in Algebra 2, and I think you did a fair bit of it in Algebra 2. So what we're going to be doing is we're going to be solving rational equations. And I think you're going to think this is fairly simple. Solving rational equations. The word rational, what is rational? We've used that in here over the last couple of days. We call these rational equations right here where you had some fraction and we graphed it, but it's an algebraic fraction. So the difference here is if we solve a rational equation, it's going to be something like this. I'm going to take x and I want to add to that 4x over x minus 3 and set it equal to 12 over x minus 3. And I want to find out values of x that actually make that sentence true. But before we ever start that problem, the question that I have, is there a number that if I did my work and it showed up, I would know that that answer would be bogus? Can you tell me any number in there that if I did my work and it showed up, it couldn't be true? Is there a number that would kind of trouble you if it showed up as a result? Is there an answer that would not really truly be a legitimate answer?
3.
Is there a number that's not in the domain? Thank you, Asa. Isn't 3 not even in the domain? So as a hint, in Algebra 2 and in my class, that's almost a hint. If you do this problem and the number 3 shows up, you're like, money, I did this problem right because you're screwing with me. We do it every time. You just have to know that. If that shows up as an answer, you did good math, but it means it's called an extraneous solution. You guys heard that in Algebra 2, didn't you? Like that extra solution that couldn't work. So in this problem, the first thing that I would do is I look at all those crappy fractions and I'm like, I want those to go away. So what should I multiply by so that all those fractions are going to be gone? What's my fraction buster? Isn't x minus 3 my lowest common denominator? So if I went through and I hit every single piece by x minus 3 all the way through, what happened to the fraction on the far right? What did it become? It became 12. That's nice. What did this fraction right here become? The x minus 3 is canceled again. It became 4x. Then over here, the x minus 3 and the x, this is the one place it did not cancel out. Now, you guys should know this pretty well. What do you do anytime you have a quadratic that is not equal to 0? What should we do? We always make it equal to 0. So if we combine my like terms, x squared plus x, and if I bring the 12 to the other side, I'm right here. Now we have 3 ways to solve this, and 2 of them are completely stupid in this case. We could factor, we could complete the square, or we could do the quadratic formula. Which one should we start with? As a rule, I told you always start with factoring. Can you guys come up with 2 numbers whose product is negative 12 that have a sum of 1? 4 and 3. What kind of 4? What kind of 3? There we go. So what are the 2 answers that would make that go to 0? Negative 4 is one of the answers, and what's the other answer? 3. And as I warned you at the beginning of the problem, what does that tell you about this answer right here? Is it almost tells you did it right because your teacher was trying to be mean and made sure that that was a bad answer that we wanted to make go away. So this is a bad answer, and we're going to cross that one out because that is an extraneous root. Now what I can tell you is on your next exam, every freaking year, I warn everybody about this over and over and over and over again, and I make sure that everybody hears the message and hears it well. And what do half the students in here do? They get me both of those roots and they smile and they move on and they don't remember to look back and see, is it actually even possible to answer what I just answered? Please, guys, look back. Please prove that everybody else was dumber than you are, that you can actually, I know there's a lot of things to watch for, but that's such an easy thing to look back and make sure it's in the domain of the original problem. So far, is that a pretty, I mean, is that a little easier than graphing? That was a little easier than graphing. It was, I'm sure, significantly easier than dealing with logarithms. Okay, so let's check out number 2, and that's about as far as I was hoping to go today. I just wanted to show you a couple of them, and then when we come in tomorrow, we'll go a little further. So in this second problem, it's a little bit trickier. But before we start it, what I notice right away is this is factorable, isn't it? What is x squared plus x? How does that factor? What goes into both x squared and x? Now, that's a little bit of a hint that we're probably on the right track because you notice these both have an x plus 1 in common, right? That tends to happen. We're just trying to be kind of nice to you so that when you go for that lowest common denominator, what should I multiply everything through by to make all of those denominators go away? I want to multiply by an x and an x plus 1. So if we do that, all 3 pieces of this story, what's going to happen in the far right? What does the entire thing turn into? It turns into just plain old 1. Good. What does this term turn into? Careful about the pluses and minuses. See, the x cancel, the x plus 1s cancel, the x plus 1s cancel. What's left? A negative 1x. Perfect. And then the last one, I kind of always do that myself because this is like the easy part. I usually do the easy parts first. And then over here, what do you really have? I don't have x squared plus x. I should have 2x squared plus 2x, right? Because I have x times x plus 1 is this, but it still has that 2 in front. So what should we do to solve that one? Should we again try, if we can, to factor? I think I'm going to. I mean, I don't know that it's going to work, but I'm hopeful that it will. So right off the bat, what's the only way I can get 2x squared? 2x and x, right? And the only way I can get a 1 is a couple of 1s. So I mean, when we say guess and check, that's pretty hard to call that guess and check. We had one option, right? Now the only thing I got to figure out is A, did it work? And B, what pluses and minuses would make it work? So I need a 2x and a 1x to make a 1x. How? 2x and a 1x would make an x if the 2x was positive. And so what are the answers? What made it work? Positive 1/2 and x equals negative 1, and we just got smacked by our teacher on the test. Why? Because x equals negative 1 right there was an extraneous solution. So do we need to really, really watch for that? By the way, as much as it's a bad thing, it also should make you smile and go, sweet, I know I nailed that. Now on the test, here's another thing. Could you type this as y1 and this as y2 and see if you plug in a half into both, will they in fact give you the same answer? Because if you did that, that would tell you something. In fact, in the last couple of minutes that I've got, I'm going to go ahead and do that. So I'm going to go ahead and type in the left side, right? 2 minus 1 over x plus 1. And the other side, x squared plus x. And let's see what happens if we go over here and check out my table. Now, my two answers were 1/2. Did it work? Look at it. Do you see, did I get exactly the same thing for both? That tells me that I did good, right? What was my other answer we said? We said 1/2, and what else did we say? I think we said -1. Watch what happens when I ask for -1. And my calculator's like, no. See, there's no reason at all ever to miss one of these questions, especially with extraneous, because if you check yourself, your calculator will even flick you in the ear and say, knock it off, dummy. See? It says, don't do that. That would be a bad thing, okay? So that's the end of the day. So what's your homework? Make sure your 2-1 to 2-5 review is done, and try to do those. I guess it's just a total of 5 graphs. It wasn't super, super long. Can you check all your answers in Desmos? Yeah, please look at them and make sure that you're doing good quality work. And we will resume our journey tomorrow.